this, we have 2 points here, this point and this point. From what? From this point, number 1, and we have another point here, number 2. So this is what? This is 2 points to connection. And here we have a copper wire. This copper wire, it makes what? It makes connection in this electric circuit and make the electric current intensity moves inside. So this one, or this voltmeter here, it's connected in series connection? No, it is not series, mister. Why? Because here we have the voltmeter, it is above the piece of what? Of the copper wire. If I put another device like this, replace the copper wire here, what will happen here? We have what? We have another type or another reading of a meter, and we have another reading of voltmeter. So this device, it is another device that called resistance, and we will talk about it after a period of time. So here we have what? We have the voltmeter, it is what? It makes the measuring of what? Or it measures what? Measure the potential difference between these 2 points, the point number 1 here and the point number 2 here. So the voltmeter, it's connected in parallel connection. What's meant a parallel connection? It is above the part that measure or that pass the electric energy from the positive to negative. After that, we have the measuring device of voltmeter. The measuring device of the potential difference is voltmeter, and this picture represents the voltmeter. It is one of the real voltmeters here. And after that, it's connected in parallel connection. What's meant a parallel connection? It is above the part that measure the voltage or the potential difference between them, or between 2 points of this device. Like what? Like the piece of copper, or the copper wire, or the resistance that we will talk about it after a period of time. After that, here we have the electric resistance. It is another new concept. So the meaning of electric resistance, the definition is very important here. The electric resistance, electric current intensity, and electric potential difference. So they are 3 of the concepts that very, very important to know the definition about them. It's the opposition of the electric current. It's what? It is electric resistance here, that's symbolized by R, R capital. So here it is the opposition of the electric current, or electric current intensity, to pass in the conductor from point to another. It's what? It's prevent or decrease. Opposition, it means decrease or prevent the electric current intensity or the flow of charges that move in the wires. So it is the opposition of the electric current to pass in a conductor from point to another. The measuring device is ohm meter. Here we have the phrase meter. So here it is ohm meter. What's meant by ohm meter? It's the measuring device of what? Of the electric resistance. After that, we have the measuring unit is ohm. What's meant by ohm? Ohm, it's the name of the scientist that discovered the electric resistance by an experiment. So this ohm, what's meaning by ohm? So ohm, it is resistance that's produced by passing 1 ampere in the conductor when its potential difference between 2 points in the conductor is 1 volt. We have the factor that affected on the resistance. This resistance, it has the length of the wire. Resistance of the wire directly proportional to the length of the wire. What's meant by this? We have the direct proportion. It means if I have increasing of the wire or a long wire, so its resistance is very, very high. But if I have a short wire, it's what? It is very low resistance. And we have in resistance increases by increasing the length of the wire. It's very easy. Why? Because the electric resistance, it is directly proportional to the length of the wire. If I have give reason, for example, as a question, we have give reason. Resistance increasing by the increasing of the length of the wire. Why? because the length of the wire resistance or the resistance that of the wire directly proportion to the length of this wire. Here we have our circuit. This circuit, it contains what? Contains voltmeter, and we have ammeter, and here we have a part of the wire that called what? That called rheostat. And this rheostat, it has what? It has a wire here. This wire, it's what? It makes what? It makes increasing or decreasing here or here. So here I have what? I have very small one of what? Of the electric wire here. If I put a wire like this here to what? To make what? To make decreasing or to make closing of this electric circuit, what will happen? Here I have what? I have the nickel chrome or nichrome wire. It's what? It is a type of material that has high resistance. So here if I have the ammeter, it's 2.7, and we have the voltmeter, it's 3.5. After that, if I change the type of the copper or the copper wire here, and here we have the electric current intensity, it will be 10.2. Why? Because the resistance of the nichrome wire is more than what? More than the copper wire. If I replace the copper wire by this type of resistance here, it makes what? It makes the 4.2 amperes. This means what? It means decreasing of what? Of the electric current intensity due to the material. If I have another one of these diodes, it's another type of resistance. We have what? We have 6.6 watt, 6 amperes. Why we have this? Because we have many types of what? Many types of material. If I put the copper wire again and I use this rheostat or resistance here, or the coil that found in this rheostat, in what? In this electric circuit. Here I have 10.2 amperes. It means high electric current intensity. So here we have what? We have very small what? Very small wire here in this coil. After that, if I increase this one, increase the part here from the beginning of what? Of this coil to this pointer, what will happen? Here we have the ammeter that has reading 8.7, and here the voltmeter, it's 3. Concentrate with me very well in here in this circuit. If I increase it like this, what will happen for the ammeter? It is decreases again to 7.3, and the voltmeter decreases also 2.5. And if I increase this one again, the electric current intensity that decreased by what? By increasing the coil here. So the resistance, if you increase the coil wire here or the length of the wire, the ammeter or the electric current intensity will decrease and the voltage will decrease. So here another one, we have what? We have this one, and if I increase the wire here from the pointer to the beginning one, to it makes what? It makes the electric current intensity decreases again to what? To the end of this one like this. We have what? We have 0 voltage and we have 0 ampere. Here we have a closed wire. Yes, we have a closed circuit. Yes, but we have here high length or very long length of what? Of the electric coil or electric wire here in this resistance that makes no electric current pass. So here we have the electric resistance. It is very important to control the electric current intensity and the voltage here in these circuits. So here the factors that affect on the resistance, again the length of the wire, that resistance wire direct proportion to the length of the wire due to the resistance increases by the increasing the length of the wire. Another factor we have the cross section of the wire. The resistance is inversely proportional to the cross section of the wire. Why? Because if I have a cross section of the wire is very thick one, so it has what? It has very small amount of resistance. And if I have very thin one, it's what? It has very high amount of resistance. So here we have the potential difference, or the cross section is inversely proportional with the cross section. And the resistance here, it is increases by what? By decreasing the cross section of the wire. and the type of wire material that we said before. After that, we have the types of resistance. We have fixed resistance and we have variable resistance. It's called rheostat. What's meant by rheostat? It is a variable resistance. And we have another type of this resistance. It's called fixed resistance. Fixed resistance, we have many pictures of this one. And we have the second one, we have the variable resistance that called rheostat. The first two pictures represent the first the fixed resistance, as we said before in our circuit before a period of time. We have this one, or the first picture and second picture in the fixed resistance represent this type of resistance. But the second one, we have variable resistance. We have a pointer that move around around the coil. This is a resistance that found in our school lab. So this resistance, it's very important to control the electric current intensity and to control the potential difference of each part of the electric circuit. So here we have two types of resistance here. It makes fixed resistance, and we have variable resistance, or it's called rheostat. We use these things to make what? To make relationship between the three concepts here. So here we have what? We have Ohm's law. This is a scientist that called Ohm. His name was Ohm. And Ohm, it makes small experiment to make what? To make this what? To make the relation between potential difference, electric current intensity, and the resistance as the following. It makes what? It makes a law. This law, it states that, state what? State the electric current intensity is directly proportional with what? With the potential difference between 2 points in a conductor in normal temperature. And we have the rule here, R equal V divide I. What's meant by this? Let's go to see. Here we have our circuit again. Hello, our circuit. How are you? Here we have what? We have the V. It means voltmeter. And here we have a meter. And this one is called rheostat. So here we have what? We have the electric copper, or this copper wire. So here we have the connection in what? In the circuit. So here we have an electric current that move from what? From the battery to what? To the resistance or rheostat, to what? To the ammeter, and to what? To the voltmeter. The ammeter is found here in what? In the series connection, and the voltmeter, it's parallel connection. And here we have a wire, or this is the key that close the electric current intensity path. After that, if I increase or decrease the coil of rheostat like this, what will happen here? Here we have 0.9 amperes and we have 0.5 volts. What will happen after that if I decrease the coil here? The coil, here we have 2.9 and here we have 1 volt. It increases to each other. What will happen here? So here we have what? We have increasing in the first step and the second step. Let us see the third step. What will happen? It's 4.4 amperes and 1.5 volts. It increases also. And after this we have 6 amperes and 2 volts. What will happen here? Here we have increasing of amperes here with the increasing of the volts here. Why? Because the electric current intensity increases. With what? With the potential difference. So here we have a relation between the voltage or the potential difference and what? And the electric current intensity. Ohm said that. So here if I increase this one or this ammeter here 8.7 and here we have 3 volts. So here we have what? We have increases to each other. And after that in last time we have 10.2 amperes and here we have 3.5 volts. So here we have what? We have the parts of or the electric current intensity and the potential difference increases with each other and decreases with each other. If I decrease like this, I have this is decreases from 10 to 8 and the voltage from 3.5 to 3, and this is decreasing with each other again, and here we have decreasing again. So here we have a relation between what? Between the reading of voltmeter here, and we have what? We have the reading of a meter that represent the relation between electric current intensity and what? And the potential difference. So here we have what? We have a relation between them, direct proportion between V and A. After that, this is the experiment of Ohm's, George Simon Ohm, that make this experiment. We have a table and we have the voltage. Voltage is 0, 0.5, 1, 1.5, 2, 2.5, and so on. Here we have the electric current. It is 0, and we have increasing each step or each time with what? With V. So I have a result. This result is what? V, or potential difference, and electric current intensity I, it's increase with each others and decreases with each others. It means what? It means V direct proportion with what? With electric current intensity. So it is what? It is Ohm's law. Dear friends, I hope to enjoy your time with us. Try to study this information about the electric energy and the electric current intensity, the voltage, or the potential difference many times in your books. Try to answer the questions about this lesson about Ohm's law many times. Till we meet again, thank you and goodbye everybody.